Okay, let's unpack this. Imagine a hidden genetic thing
Yeah.
affects hundreds of millions of people, often totally silent, right? Until some common trigger just, well, unleashes a health crisis.
Yeah.
Today, we're diving into G6PD deficiency, that's glucose 6-phosphate dehydrogenase deficiency. Its impact is, frankly, pretty eye-opening.
Yeah, what's really striking is how this one single genetic variation, often no symptoms at all, can suddenly cause this cascade of quite severe health problems. That happens when red blood cells hit oxidative stress. This deep dive, I think, will really show its surprising global reach and, the profound implications.
And here's something I found really interesting in the research. It's particularly common in places like Southeast Asia, Thailand, for example. It affects something like 8 to 13% of men there, which is, well, huge. And it's not just random chance, it seems linked to protection against malaria. So understanding that kind of evolutionary trade-off is
Yeah.
pretty key for grasping its impact on daily life and, well, public health strategies for you. So let's get into the core problem. G6PD is an X-linked genetic condition. Could you maybe break down what that means for our red blood cells? Why is this enzyme so vital?
Certainly, yeah. X-linked basically means the gene is on the X chromosome. And in this condition, the red blood cells just don't have enough of this G6PD enzyme. Now, this enzyme is absolutely critical for making something called NADPH. Think of NADPH as like a shield for the red blood cells, an
Yeah,
antioxidant.
the shield.
Exactly. And without enough NADPH, these cells become incredibly vulnerable to oxidative stress. And that stress can be triggered by, well, common things. Certain drugs, some foods, even just getting an infection. This leads to a really rapid breakdown of red blood cells. It's called acute hemolysis.
Right, and that hemolysis, that breakdown, it isn't minor, is it? The consequences sound pretty severe.
Oh, absolutely. It can lead to severe anemia, jaundice, where you might notice yellowing of the skin or eyes, sometimes dark, like cola-colored urine,
Right.
and in the really serious cases, acute kidney failure, which can be life-threatening if it's not managed fast.
Wow, okay, so if it's this common and potentially this severe, how do we manage it? How is it dealt with?
That's a really important question. The World Health Organization, for instance, they just updated their guidelines in 2024. They're really emphasizing how critical screening is, especially before using certain anti-malarial drugs, things like primaquine or tafenoquine. These are known triggers for people with G6PD deficiency, so you need to know beforehand.
Okay, that makes sense for prescriptions. But what about everyday things? Are there other triggers people need to watch out for? I think I saw something about beans.
You did, absolutely. Fava beans. For some individuals, particularly those with what's called the Mediterranean genetic variant, just eating fava beans can trigger a severe reaction. That specific reaction is known as favism. It's a really stark reminder that even your diet can play a huge role here.
Favism.
Mhm.
Okay, so screening is key then.
Definitely. And the good news is many countries, including Thailand, actually, since 2007, they've implemented newborn screening programs, which is
Yeah.
great. And hospitals are also getting better at this. They're developing what are called pharmacovigilance systems. These are essentially robust systems to monitor for adverse drug reactions and alert doctors about risky medications when they're prescribing for you.
That sounds like a really crucial safety net. Looking forward then, is research offering new hope? What's on the horizon beyond just managing triggers and screening?
Oh, the research pace is genuinely exciting right now. Scientists are exploring some really cutting edge stuff, gene therapies, for instance. They're looking at using special viral vectors, kind of like delivery trucks, to insert a normal copy of the G6PD gene into cells.
Wow, actual gene therapy.
Yeah, and there are other precision approaches too, like small molecule chaperones. These are tiny molecules designed to help stabilize the faulty G6PD enzyme that the person does have, make it work a bit better. And perhaps more immediately impactful, especially for, say, rural areas, is the development of next-gen point-of-care diagnostics. Imagine getting a G6PD severity test result in just maybe 2 minutes. That could revolutionize access to care.
2 minutes, that's incredible. So putting it all together, G6PD deficiency is this amazing example of how one tiny genetic detail can ripple through biochemistry, genetics, public health. It affects so many people worldwide. It really brings home the importance of understanding our own genetic makeup, doesn't it?
It absolutely does. And our deep dive today, I hope, shows that while it's definitely a challenge, ongoing research and, importantly, multidisciplinary care are doing more than just managing symptoms. They're genuinely starting to transform the future for people affected. And maybe, the provocative thought for you listening is, how many other silent genetic factors like this are shaping our health, shaping our evolution, even in ways we're only just starting to understand, just beginning to map out?
That is a profound thought.
Yeah.
And definitely a powerful reminder of just how complex, but also how resilient the human body is. Thanks for joining us on this deep dive.